we're going to discuss ratios and proportions. We've kind of been doing proportions already, but I kind of want to give you um, an overall view of what it is, so we can do them better. All right, so a ratio is a comparison of two numbers. Okay, so it can be written three different ways. The most popular way we write a ratio is a fraction. So a fraction is the most popular ratio, but you can write it three different ways. Um, the order in which you write the ratio is important to the meaning. So it's important to know what's your numerator. It's important to know what's your denominator. It's important to know what goes left, what goes right. Um, and so ratios, like fractions, they can be simplified. So here are the three ways to write a ratio. The first way is A, the word to B. So A to B, just like that. A, T-O, and then B, A to B. The second way is A and then a colon B. The way you say that is A to B. So you're comparing A to B. And then the third way, the most popular way, is a fraction, A over B. What are the letters A and B? What are they? Just, yes, variables. So A and B are just variables. Okay, so we just letters to take the place of a number. So again, it's a comparison between two numbers, and we write it through ways: A to B with the word to in the middle, A to B with a colon in the middle, or A over B like a fraction. Okay, so we have these little smiley faces here. We're going to compare. Um, yeah, it's a bunch of different emojis here. I didn't even say smiley face, some of the same emojis. A second. All right, so we're going to compare. It says teeth to no teeth. So the number of smiley faces with teeth to the ones with no teeth. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9 with teeth, right? So the comparison is 9 colon, and then how many have no teeth? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 9. I think that's a ton. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I count this one? It should be 15. It should be 15. So 9 to 15. Now my question is, can we simplify 9 to 15? Yes, you can, by 3. Okay, 3 goes into 9, 3 times, 3 goes into 15, 5 times. So it'll be 3 to 5. Does that make sense? Okay, the next one is the number of smiles to the total. Bless you. So we have 1, 2, 3, 4 smiles. 4 smiles to the total. How many are total? So we have 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, so 24. So 4 to 24. Can I simplify this?
Yes.
Yes, 4 goes into 4 one time, 2, 6. So it should be 1 to 6. And then we have the next one. It says big eyes to teeth. So the number of smileys or emojis with big eyes compared to the teeth. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, 13. Yeah, it's 12. So 12. And then compared to the ones with teeth. Remember that was 9. We did that earlier. The number of the ones with teeth are 9. So 12 to 9 like that. Can I simplify that fraction? By what number? 3. So we end up with 4 to 3. Does that make sense? So ratio, and I'll let you guys do the rest on your own time, but the ratio is just comparison of two numbers. It's important to know where we're putting those numbers. Like if we're comparing teeth to no teeth, it's important to put the teeth first and then no teeth second. If you notice, I wrote the ratio 3 different ways. I wrote it with the colon, I wrote it with the word 2, and I wrote it as a fraction. Those are the 3 ways you can write a ratio. They all mean the same thing. At the bottom, it talks about a proportion. A proportion is a term used when there are two equal. A proportion is a term used when there are 2 equal ratios. Okay, so 2 fractions, basically 2 equal fractions, and we talked about that. If they're in a proportion, those fractions are equivalent. Okay, so a proportion is a term used when there are 2 equivalent ratios, or 2 equal fractions. Okay, and proportions can be used to solve for missing pieces of information. So if you have a situation and you know that the situation is proportional, meaning you can put it in a proportion, then you can use a proportion to find that missing piece of information. Okay, so there's 2 ways to solve a proportion. We do what we call scaling, which if you're good at your multiplication facts, you will understand. If you're not good at your multiplication facts, scaling is probably not something you can do. But if you are good, then you can scale. And then the second way is the way I taught you initially, is to cross multiply and then make an equation and you end up dividing. Okay, so with scaling, what it means is if I look at the relationship from 3 to 24, what do you multiply 3 by to get to 24? By 8. So 3 times 8 gives me 24. Well, since these 2 ratios are equal, whatever I do to one side, the bottom, I have to do where? To the top. So we have to multiply 2 times 8. What do you get? 16. So x equals 16. So if you're good at your multiplication facts, that's a really quick way to solve that proportion. We see that from 3 to 24 is times 8. So from 2 times 8 is 16. So x equals 16. Does that make sense? And then the second way we do it is the way I taught you initially. It's just to cross multiply and then we end up dividing. So 3 times x is what? 3x. 2 times 24? 48. Good. And now we divide by 3. Divide by 3. X is still going to equal 16. Does that make sense?